All right, like I said earlier, this is one of those really important lessons. It's one of those lessons that really stand out. Um, and you may think that I think that every lesson is important. I don't know if you think that or not, but this one definitely is. Okay, this is one of those ones that you're going to use a lot. It's very, very famous. It's probably, if I was to guess, it's probably the most famous formula in all of geometry or all of math, maybe. Okay, so that's how important it is. All right, and it's that famous. It's got a weird name, Pythagorean. All right, it's kind of strange. Why in the world would they give a name like that to this theorem? Well, it's named after somebody. All right, it's named after a guy named Pythagoras. Pythagoras. Let's try that. Make that A a little bit better. All right. He was Greek. He lived a long time ago. Very long time ago. In fact, he lived about 500 years before Christ. 500 years before Christ. So his dates are 570 to 495. Now, why did I go the wrong way? Why did I go 570 to 495? It's what? It's not AD. It's what? It's BC, right? Before Christ. All right? So he was a philosopher. He was a mathematician. He was a scientist. He was a writer, wrote all kinds of things. Why do you think they gave this theorem his name? Why do you think they named it after him? You would think, and that's a great answer, okay, and that's kind of what I thought for a really long time, that he came up with it. He's the guy that came up with this. But they actually knew about this theorem. I think I read like several thousand years before Pythagoras was around. That's crazy. I mean, you don't even think about people way back then even knowing anything about math, do you? You think about them walking around with no shoes on, maybe some sandals, in a dress or something, and not really doing math. But they were doing math back then. They were doing pretty sophisticated math. Okay, even back then in Jesus' time, this was 500 years before Jesus was around. Okay, long time before that. And before he was around, before Pythagoras was around, they knew about this theorem and they were doing all kinds of pretty sophisticated math, even a couple thousand years before Pythagoras was even around, which is pretty amazing. So anyway, the reason they gave him the name is not because he came up with the theorem. They already knew about it, but he was the first one to give like an elegant proof, okay, for the theorem. He was able to prove it, right? There's a bunch of ways to prove the Pythagorean theorem, and maybe one day, maybe on, when are we doing the worksheet? On Wednesday? Maybe on Wednesday, I'll show you a video just recently. I don't know exactly what the years were. I mean, it was like real recent, like in the last couple years, I think. Maybe more recent than that, I don't know. There was 2 high school girls from a school, it was way down south, I think it was Louisiana, not 100% sure, it might have been Mississippi, not really sure. But there was 2 girls in an all-girls Catholic school that actually came up with a brand new proof for the Pythagorean theorem. And to tell you the truth, I don't even understand exactly what they did. I got a basic idea of what they did, but I don't understand all the ins and outs. But they made the news, everything else, they were interviewed on there. So they came up with a proof to the Pythagorean theorem that people had never thought of as a way to prove this theorem. They're in high school, and they came up with this, which is pretty cool. There's a lot of different proofs for the Pythagorean theorem. I think I'm going to show you one of them. I'm debating on that. Let me take a look. I don't think I am. I'm just going to show you the theorem. I'm going to show you how it works. If you're really interested, I kind of doubt you are, but if you're really interested in seeing a proof, okay, it's a very simple proof for the Pythagorean theorem, then you can watch my honors geometry class. Go to section 7.3. Pythagorean theorem to that, and you'll see a proof. I do it for them, okay? But for you guys, I don't think you'll really care. I don't think you'll have much of an appreciation for it. So I'm just going to show you what the theorem is, how to use it, and a couple other things about it, and I think we'll be good. But there's a lot of ways to prove it. But this guy, Pythagoras, was the first one to be credited anyway, we'll call it that, with proving this theorem. Of course, they didn't call it the Pythagorean theorem. I don't think they even gave it the name Pythagorean theorem till way after he was gone. They looked it up in the manuscripts and they saw that he did this proof. And then later on, I don't know all the history behind it. I've just watched a couple videos, and to tell you the truth, I'm fairly interested, but not that interested to memorize everything about this guy and what he did with this theorem. But anyway, it's kind of interesting if you're interested in the history of this stuff. So the guy's name is Pythagoras, and they call it the Pythagorean theorem. All right, enough of that. Let's do it. First of all, the Pythagorean theorem only works when you have certain kind of triangle, a certain kind of triangle. And what do you think this triangle is? What does it look like? Now, what does it look like? It's a right triangle, okay? So the Pythagorean theorem, I haven't even shown you what it is yet, but it only works with right triangles, all right? So if you have an acute triangle, if you have an obtuse triangle, it's not going to work. It only works with right triangles, all right? So keep that in mind. This only works with right triangles. So what we're going to do is we're going to name some of the sides, okay? Knowing the names of these sides, let's get rid of this because we're not proving this. So knowing the names of the sides really helps. Now, this is called the hypotenuse. It's a weird word. You've heard of that before, haven't you? And we've talked about that, I think, haven't we? When we talked about right triangles, talked about this side. This side is opposite the right angle. This side is called the hypotenuse. The hypotenuse is always the longest side of a right triangle, okay? It's always the longest side of a right triangle. I've had some kids do this. Let's watch this. Oops, missed it a little bit. Let's move that up a little bit. To the left. There we go. Now look at this. Look at this triangle right here. Which one is the longest side right here? Well, it's this one, isn't it? The one that's slanted like that. So this is the longest side. Is this the hypotenuse? Why not? Because it's not a right triangle. Very good. Okay, so this is the longest side. Every triangle, well, not every triangle. A lot of triangles have a longest side, but they're not always the hypotenuse. It's only the hypotenuse when it's opposite the what? The right angle. Okay, if there's no right angle, which there's not here, that's not the hypotenuse. It can still be the longest side, but it's not the hypotenuse. But on a right triangle, the hypotenuse is always the longest side. So whenever you look at a right triangle, look at the right angle, whatever side is opposite that right angle is always, 100% of the time, the hypotenuse. Everybody good with that? That's very, very important to understand. These two sides right here, we've talked about this in the past. Anybody remember what we call the other two sides? The legs. Good. All right. So that's a leg and that's a leg. All right. It's important to understand which ones are the legs, which one's the hypotenuse to be able to do the Pythagorean theorem. All right. Shouldn't be too hard. It's stuff that we've discussed in the past, but I'm just bringing it up to your memory again so that you remember. All right. Now, we give certain letters. You could make these any letters. It doesn't matter. But when people think of the Pythagorean theorem, they almost always use these three letters. And it's the first letters of the alphabet. All right. So one of the legs we call side A. We call the other leg side B. And what do you think we call the hypotenuse? We call it C. All right. So when we do the Pythagorean theorem, we almost always call the two legs A and B. It does not matter which one is A, which one is B. All right, as long as the two legs are A and B. But it absolutely matters which one's the hypotenuse. The hypotenuse on the Pythagorean theorem is always going to be what? It's always going to be C. Everybody understand that? It's super, super important. All right, so A and B are your two legs, and the C is the hypotenuse. Now, here is the Pythagorean theorem. Let's write it down. Let's write the word down again, since it's not on our screen. Pythagorean theorem. And so here it is. I like to say, whoops, what did I do that for? I like to say it's as easy as ABC. All right, why do I say it's as easy as ABC? Because, oops, let's do this. There we go. Because a squared, now where's that come from? Well, it comes from the proof. I hate to say just believe me, but just believe me, this works, okay? That a squared plus b squared equals c squared. Have you seen that before? Have you seen in Algebra 1 probably? Yeah, this is something that's not just in geometry, okay? This is all over the place. All right, so it's probably something that you've seen before. But I'm going to teach this from scratch as if you've never seen it, okay? So that's your Pythagorean theorem. A squared plus b squared equals c squared. All right? Yeah, I think I'll leave it at that as far as... Now, let's do some examples, okay? Now, again, let's talk about this for a second before I go on. What does that squared mean? What do I do to that a? Because this a could represent a number, right? It represents how long that leg is. So what does it mean to square something? By itself, that's right. So if this leg is 3, then what do we do to the Pythagorean theorem? We make it 3 squared, which makes it a what? A 9, all right? And so let's actually do that. Let's see. Let's make a little triangle. Not just any old kind of triangle. What kind of triangle does it have to be? It's got to be a right triangle. Okay? And again, I'll probably say this until it just irritates you, and it irritates me, but we only use Pythagorean theorem with what kind of triangles? Right triangles, okay? I just want to pound this through your head so that you understand you can only use this with right triangles. All right. Let's make this kind of easy. What if I said that that is 3, and this side right here is 4, and I ask you to find this side? Well, what letter am I going to use to represent that side right there? C. Now, if you look in some books, they might make it an X or a Y or a Z or something like that. They might use a different letter. That's okay. Still means the same thing. But when we look at a squared plus b squared equals c squared, the C is always the hypotenuse. You got it? Doesn't matter if this one's A or this one's B. Doesn't matter if this one right here is A or B. It doesn't make any difference because we're just going to be adding those two together anyway, right? After we square them. So let's do it. Let's solve for C. So here's what they're going to say. They're going to say solve for whatever is missing. Solve for C. Now I started off with the very easiest Pythagorean theorem problem that I could ever do, all right? Pretty much. All right, so let's solve for it. So we're going to put it into our formula. So we go a squared. Which one do you want to make a? 3? All right, it doesn't matter, does it? We could have made that one a, or we could have made that one a. So if this is a, what's the 4 going to be? It's going to be b. And then the c, we don't know, do we? All right, I'll put a question mark there. That's what we're trying to find. So let's plug it into our formula. So we start off with a squared. So what am I going to write? Well, not a. I know the number now. It's 3 squared. It will be 9, but we're going to we'll put the 9 in a second, right? So let's write it like this. Don't try to do too much in your head at the beginning. Just write it like this, 3 squared. So what is it? There's your a squared plus the b squared. So this is plus. What's the b? It's 4, and we square that. And what's it equal to? C, not just c, but what? C squared. All right? It'll get a little bit weird, okay? I want to do several examples before I do the one that they give. The example they give, for example 1, it's not something I'm going to give you on a quiz or a test in here, okay? I just find it hard to believe they do that as the first example. I think what they're thinking is, you probably already know this. This is just a refresher, so they're going to start off with a hard problem right away. But this, I'm treating this as if you've never seen it before, all right? Even though you have. All right, let's do it. 3 squared is what? 9 plus 4 squared is 16, and that's equal to c squared. Now what do we do with these two? Add them up. What's 9 plus 16? It's 25. So I go 25 equals c squared. Is that my answer, 25? Do I circle it? Is that length 25? Nope. Now here's what I got to do. Everybody watch very carefully. Donnell, you getting all this? Okay, this is super important. This is the key to this whole entire problem. All right, is you want to get c by itself. We're solving for c, not for c squared. So I got to get rid of that squared. How do I get rid of something that's being squared? You don't divide. What's the opposite? Remember, we always do the opposite. What's the opposite of squaring something? Square rooted. Exactly right. So you remember square roots? We're going to talk about that here in a minute. Okay, so square rooting it is the opposite of squaring something. So if I square rooted this, and what does that look like? You've seen square roots before, haven't you? Some kids call it like a check sign. It looks like a check, kind of. All right, but that's a square root. So if I square root one side in algebra, what do I have to do? If I do something to one side, what do I got to do? I got to do it to the other side. So I'm going to square root this side. All right. So let's do the c. If I do the opposite operation, what happens to it? It cancels it out, right? All right. So that square root does what to that squared? It cancels it out. Everybody see that? All right. So what am I left with over here on the right-hand side? Now, on the right-hand side, just a c. Now, what's it equal to? 5, because the square root, what does that mean to square root something? It means what number times itself is equal to 25. Okay, so it's not 25 squared. It's not 25 times 25. You have to think of a number that if I multiply it by itself, two of the exact same numbers multiplied together equals 25. What is that number? That's a 5. So if you wanted to write it with a c on the left-hand side, you could always do that. Just c equals 5. And there you go. And that's what that's equal to right there. So that length will be 5. Now this is a special type of triangle. Let's talk about this now. This is a special kind of triangle. Do you see how that's a whole number, that's a whole number, and that's a whole number? It's not always going to be like that on right triangles, okay? Sometimes you get some weird numbers for either the legs or the hypotenuse. But when they're all whole numbers like that, we call this a Pythagorean triple. Pythagorean triple. Okay? Why triple? Well, because there's 3 sides, right? All right, it's Pythagorean triple. What this means, Pythagorean triple, is when all 3 sides are nice whole numbers. There's no decimals, there's no square roots, it's just nice whole numbers. And that really doesn't occur very often on right triangles. Okay, it occurs, but not all that often. So our first Pythagorean triple is called a 3, 4, 5, and a lot of times we'll say triangle. So that's a 3, 4, 5 triangle. That can be very, very useful. You guys, was it next week you're doing the PSAT? Is it? Did they schedule for it? What is it? 15th? Okay, so it's a couple weeks away. All right, so this can be very, very helpful because there's a lot of times, watch this. Instead of going through all this right here, if they gave you one leg is 3 and the other leg is 4, now that you know about Pythagorean triples, you don't even have to go through this right now. We did it once to show you what it's equal to. But you should just be able to look at it. This is kind of like a little shortcut. And it's very, very helpful. I've seen this on the SATs. It's probably on the PSAT. I don't know if it's going to be on the one that you're going to take or not. All right, but I've seen it before. All right, you could just solve for C in just a second, literally a second, 1 second. All right, if I see 3 and 4, what do you think that hypotenuse is going to be? It's going to be a 5. Okay, what if we did this? Watch this. Let's do this. What if the hypotenuse was 5 and one of the legs was 4? In just a matter of seconds, you should look at it and say, what 4, 5? What is it? That would be a 3. Without doing the math. okay, you should be able to figure out that that's a 3. Does that make sense? All right, and that's a nice shortcut. These Pythagorean triples really come in handy. So check this out. What if this side was 3, you didn't know this side, and that side's 4? Or, I'm sorry, 5. I was thinking of the answer. So what is B? Without even doing the math, that's going to be a 4. You see that? So it's really, really handy, and you can get a problem done very quickly if they give you that situation. So that's one of my Pythagorean triples. There are others, but what I'm going to do, and we're going to list the others in a few minutes, all right? But what I want to do is I want to change this up just a little bit. I'll tell you what, let's get rid of this. And yeah, let's get rid of this one. I'm going to put some other numbers in here, okay? Well, I could keep the equals there. It doesn't matter. All right, so watch this. What if I said that this was 9 and this was 12, and I asked you to solve for C? Now, one option is the long way about this. You could do the Pythagorean theorem. All right, so if we were going to do the Pythagorean theorem, let's do it. I just want to show you. So what would we do? I'd go what? 9 squared plus 12 squared equals C squared. Now, these numbers are a little bit bigger, but if you have a calculator, it shouldn't be that big of a deal for you. So 9 squared is 81, plus 12 squared is 144, and that's equal to C squared. What's that? That's a 5. 225, is that right? 225. Now, this is a number that you probably are not familiar with. What are you going to have to do, though, to get it? You got to take the square root of both sides, and you could always put that into your calculator. Square root of 25 or 225 is actually 15. So I could write 15 right here. But look, you could have done this without all this work. How could you have done that? Everybody look up here. I'm saving you lots of time. I got some heads down. You got it, okay? So look at this. I got a 9 and a 12. What number goes evenly into 9 and 12? 3 does. Okay, 3 goes into 9, 3 goes into 12. 3 goes into 9 how many times? 3 times. 3 goes into 12 how many times? 4 times. So, how did you get that 9? You went what? 3 times 3. How did you get that 12? You went 4 times 3. Look, I got a 3, 4, what? 5 triangle, but this is not going to be 5. It's going to be what? 5 times 3. Again, how'd you get 9? 3 times 3, how'd you get 12? 4 times 3, how'd you get this? You went 5 times what? 3, which is 15. So this is still a Pythagorean triple, isn't it? It just kind of reduces to a 3, 4, 5. You see that? So it's kind of helpful. I don't know. Are you getting this or not? So let's do another one like that. Let's say this is 15. And that was 20. What do you think that's going to be? 25. Because why? Because, look, what goes into 15 and 20? What's the biggest number that divides evenly into 15 and 20? 5. So, this is my shorter side. So this, so 5 goes into this how many times? 3 times. 5 goes into this how many times? 4 times. So how did I get 15? I went 3 times 5. How did I get 20? I went 4 times 5. This is a what? A 3, 4, 5 triangle. So what do? 5 times 5, which is 25, and there you go. Instead of having to go 15 squared plus 20 squared, all right? And if you had a calculator, it's really not that big of a deal. But don't you agree it's a little easier doing it this way? Yeah. So do you see the, I don't know, what's I'm trying to think of, it's just regular words, not a hard word. I don't know. Do you see the benefit, I guess? Do you see the benefit of knowing that this is 3, 4, 5? Now, is every right triangle going to be a 3, 4, 5 triangle? Not at all, okay? I'll tell you what, before I go on to that, I got some time, so I got some time to do this. It's kind of where I'm going to end up anyway, was with this Pythagorean triple. Well, no, I'm going to do some other stuff too. Let's get rid of all this. All right. Here's some more Pythagorean triples. You want to see them? Let's make this yellow. I'll keep this going. So look for these numbers. Here's some other ones that you're going to get whole numbers for. All right. You got a 5, 12, 13 triangle. Okay. You've got a 8, 15, 17 triangle. And there's more than these, but you probably won't see any more than this. All right. So these are all Pythagorean triples. What does that mean? That means if this side is 5 and if that side was 12, what is this side right here going to be? What's that hypotenuse going to be? It's going to be 13. If you don't believe me, you can do the work. You're like, all right, Mr. Hamrick, I believe you. You don't have to do it. Well, I'm going to do it anyway. All right. So let's do it. Let's make sure that's 13. So what is that? It's 5 squared plus 12 squared equals, let's pretend we don't know it. I'll call it c squared. 5 squared is 25 plus 12 squared is 144. That equals c squared. 25 plus 144 is 169, and that's equal to c squared. Take the square root of both sides. I'm going kind of fast, but I've done it a couple times already, right? You see what I'm doing? So the c's, or the square root and the square cancel out, so c is equal to square root of 169. If you don't know that, you can always put it into your calculator, all right, and you'll get 13. So c is equal to 13, just like we said it should be. Everybody see that? All right, awesome. Man, I thought you had a question about this. I really did. Yes, do you have a question? No, you got to go to the bathroom too? Oh my gosh. See what you started? Just told you to wait. Why didn't you go in between classes? All right. All right, let's take a look. So what if I gave you this? What if I didn't tell you that side right there? What if I made it an X? I'm not even going to use A and B this time because they don't always use A, B, and C. All right, they might use different letters. So look, what if I gave you this and I told you to find X? You really wouldn't have to do any math at all because you're like, oh, I got a 5 and a 13, and you got to think to yourself, oh, that's right. I got a Pythagorean triple that's got a 5 and a 13 in it. What was it? It was 5 what? 5. Come on. Just think. It's right in front of you. Just pay attention. Come on, talk to me. All right? I think you're just dying on the vine here. Come on. It's 5, 12, 13. Okay? So right here, 5, 12, 13. So if this is 5 and that's 13, what must this be? That must be 12. Okay? Remember, these last numbers right here have to be the hypotenuse because they're all the longest sides. So what if I had this? Now watch carefully. This is super important because this could cause some trouble. I'll tell you what, let's go back to that 3, 4, 5. All right, we'll make it a little easier, keep the numbers a little smaller. Watch what happens here. What if that was 3 and that was 5? Is that going to be 4? Is that a 3, 4, 5? No, it would only be 3, 4, 5 if the 5 was the hypotenuse. Is the 5 the hypotenuse? No, it's not. So let's do some math and figure out what the hypotenuse is. Remember I said they don't always come out to be nice whole numbers? Here's a situation where it's not going to come out to a nice whole number. All right, so let's watch. If I wanted to solve for this, let's call it X. If I wanted to solve for X, or you could call it C, but sometimes the book uses X. Trey, you getting all this? Okay, if you wrote it down, it would be helpful. It might keep you awake. So what would I do to solve for X? If they told you to solve for X, what would you do? Do the Pythagorean theorem, right? So it's 3 squared plus what? Plus 5 squared equals, in this case it's X and not C, it's X squared. So let's do the math. 3 squared is 9, plus 5 squared is 25 equals X squared. Add them up. 9 and 25 is 34 equals X squared. We got to get X by itself, so what do? Square root both sides. So what's X equal to? It's not just a 34. What is it? It's the square root of 34. And that's your answer. You don't write anything else but that. It's a weird looking answer, but that's the answer. So if I was to put that into a calculator, it's probably like 5.8 or something like that is my guess. I'm going to put it in right now, 34. Yep, I was right, 5.83. So this right here, if I put it into a calculator, I'm going to put a squiggle right there because it's approximately 5.8. Does that make sense that it should be 5.8? Yeah, because that's the longest side, right? 5.8 is bigger than 5. It's bigger than 3. So that does make sense. But I would like you just to keep your answer like that. Just keep it as a square root. But again, the square root of 34, if you put it into a calculator, it's almost 6. How did I know it was 5.8? Is it because I'm super smart and I'm the teacher? Nope, got nothing to do with that. First of all, I'm not super smart. Now I am the teacher. But how did I know it was close to 6? Because if this is close, 34 is close to 36, isn't it? Okay, and what's the square root of 36? The square root of 36, watch. The square root of 36 is 6, isn't it? Square root of 34 is just a little bit less. Do you see how I guessed 5.8? And it was a complete guess. Not a complete guess. I knew it was in the upper 5 point something. Okay, 5.7, 5.8, 5.9, around there. I got lucky and I guessed 5.8. All right, so you got to know what these things mean. A lot of people go through this stuff and they are taught square roots and they still walk out not having a clue what it means to take the square root of something. What it means is what number times itself, what two of the same exact numbers multiplied together is equal to 34. Well, there's no whole number, is there? Something times something equals 34, or something times itself is 34. No, there's no whole number. There's something close, 36, right? And that's a 6. But there's no way to find this out unless you put it into a calculator. Stick it into a calculator. I mean, there is a way to figure it out, but as far as we're concerned, you put it into a calculator, you get 5.8. But unless I say to put it into a calculator, just keep it the square root of 34. That makes it a lot easier. So that's how you would do one of these that doesn't have, it's not a Pythagorean triple. Let's do a couple more. Now, this would be really important. In fact, let's put a box around it. That thing right there. It's good to know your Pythagorean triples. At least know a 3, 4, 5. That's an easy one, right? It just goes in order. 3, 4, 5. That can really help you out from time to time. A 3, 4, 5 triangle. And again, if we doubled it, if we tripled it, we already talked about that earlier. 5, 12, 13 pops up every once in a while, and every once in a while you'll see these as well. There's more of these. I don't even know what they are. Okay, I could look it up. I could probably Google it, give me all the Pythagorean triples, and they could probably give you 100 of them. But then they would start to be like really gigantic numbers, all right? But these are your basic Pythagorean triples. It just saves you time. Could you find 17 if you knew 8 and 15? Yeah. 8 squared plus 15 squared, add those up, take the square root, and that'll give you 17. What about this? 7 squared plus 24 squared. Square them, add them up, take the square root, you'll get 25. So you could find these on your own. It's just nice to have them memorized because you don't have to go through all this work. All right, wouldn't that be nice? Of course. All right, let's do a couple more of these. And then tomorrow we'll talk about the converse of the Pythagorean theorem and something else. Okay, but this is all we're going to do today. I got just a few more minutes, so let's make another right triangle. I'll just make it look like this and put a right angle in there. I'm making up numbers now. Give me a number, not something crazy. Don't give me like 1,000 or 100 or anything. What is it, 5? Okay. What do you think this looks a little bit longer than that, so what do you think this might be? 6, okay. And let's find C. All right. Are you writing this down? You should be writing it down. You should be trying this before I even do it. So let's write it in the Pythagorean theorem. What do we write? A squared plus B squared. What's my A and my B? 5 and 6. Okay, so it's what? 5 squared plus 6 squared equals c squared, because I don't know what the c is. Let's do the math. 5 squared is 25 plus... he's not here today. Plus 36 equals c squared. And then what's that? That's 11. That's a 7, 8, 81. Is that right? Oh, that's a 5. 61. Yeah, I was going to say, it is not going to come out even. Here, give me that thing. Where's your book? You always give me a book all the time. You got all these pages in between. Threw it away. All right, what is this? This is 61, not 81. What was I thinking? Equals c squared. So what's c equal to? Square root both sides, what's that? Come on, guys. If I square root both sides, look, if I square root this and I square root this, what is c? It's the square root of 61. All right, that's your answer. That's the way you leave it. Just leave it like that. Okay, it looks weird. It's like, I have no idea what that means. Well, you should have a little bit of an idea. Because, I don't know, what do you think it's between? Between what number and what number? Like, is it bigger than 8 or smaller than 8? Why smaller? Because if it was an 8, it would be the square root of what? 64. So the square root of 64 is 8. So the square root of 61 is just what? A little smaller than 8. So it's probably 7 point something. Agreed? All right. Did you get it, Evan? What'd you get? 7.8? Yep, that's another 7.8. No, not always going to be 0.8s like I've been doing here, but that's what it would be. Let's do another one. Let's use the same triangle so I don't have to redraw it. Let's get rid of all this. Okay, so now, this time I'm going to give you the hypotenuse, okay? I'm going to trick you up a little bit. Okay, so give me a number. I don't care. Give me a number for that. 15? Okay. And let's make this 7. This is a little bit bigger, so let's make that 9. Can that work? You remember a long time ago we said, can you make a triangle? What has to be true with these two? These have to add up to be bigger than the third side. Do they add up to be bigger than that third side? Yes, they do. All right, so that's legit right there. That's a legit triangle. Oh, I lied. Let's do this. That was dumb. Let's see what that is. Now, it's not going to be a 9. I can almost guarantee you. What if I asked you to find x? And that's what they're going to do. They're going to say solve for or find, okay, whatever variable. So what are we going to do now? This time they give you the c. You're not solving for c, but you're still going to put it in Pythagorean theorem. All right? So here we go. You could take the 7 squared first, but since the x, we don't know that, I like to do that first. So I'm going to go x squared plus, what's the other leg? 7. So I'm going to go 7 squared. What's that going to equal? The c squared, or the hypotenuse squared, which is 15 squared. And now we got to solve for x. So now you got to watch very carefully here. Write this down. If you're not writing this down, you're going to get lost. So it's going to be x squared plus 7 squared, which is what? 49 equals 15 squared. That's 225, I believe. All right, so you got it set up. All right, again, this is definitely a place for your calculator. What you want to do is you want to get x by itself. So we're going to go minus 49 minus 49. That cancels. Bring down the x squared. So let's see what we get. 225 minus 49, and that's 176. 176. Is my answer 176? Do I put a 176 right there? No, I got to take the square root of both sides and whatever that is. You could just keep it the square root of 176. It's a weird looking answer, but that's what it is. And that's about 13 point something. 13.26, which rounds to a 13.3. All right, but just keep it like that, unless I ask you to write it as a decimal. If I ask you to write it as a decimal, you just put that in your calculator. Most calculators, you do this. You hit 176, and then you hit the square root button. There are some calculators where you hit the square root button first, and then you put the number in. You have to know how your calculator actually works. So you're doing 1 through 10, so your homework is section 7.3a, and you're doing 1 through 10. All right? It's pages 314, 315, but you could just go to section 7.3, you look in the homework, do 1 through 10, and you should be able to do all of those with what I taught today.